Hey, sixth graders, and welcome to 10.4. Today is the very last section in chapter 10. So, welcome to the last lesson for the regular sixth grade curriculum here. Um, for section 4, we'll be talking about box and whisker plots. And then for our learning target, it's I can create and interpret box and whisker plots. So, a box and whisker plot is pictured right here in our key idea. And it says a box and whisker plot represents a data set along a number line by using the least value, the greatest value, and the quartiles of the data. A box and whisker plot shows the variability of a data set. So how much the data can vary or change is all that means. Okay. Couple things that I want to point out about this box and whisker plot. So here's the least value, here's the greatest. From the least value to the first quartile, this chunk right here is called, would be considered our first quarter of data. This is 1/4 of our data. When you use a box and whisker plot, you have 5 numbers that make up the box and whisker plot. And sometimes those are called the 5-number summary. So the 5 would be median, first and third quartiles, and the least and greatest values. So least, greatest, median, and then first and third quartiles make up the 1, 2, 3, 4, 5 numbers, the 5-number summary kind of data points. And then when you use those 5 numbers, that creates 4 different chunks of information. So the first quarter of information is the whisker, which goes from the least value to the first quartile. The next quarter of information comes from the first quartile to the median. The third chunk of information comes from the median to the third quartile. And then lastly, the third quarter to the greatest value is our last chunk. So you can see this is the second fourth, the third fourth, and the fourth set of data. When we use a box and whisker plot, it breaks our data into quarters. And you can see our box of our box and whisker plot. Let me just erase this. The box of our box and whisker plot holds 2 out of the 4 quarters. The box holds 2 out of the 4 quarters of information. So 2 out of 4 is the same as 50%. So the box tells us 50% of our data. So just a little bit of background information about a box and whisker plot there. Let's see how we can use that to create one. For example 1. It says, make a box and whisker plot for the ages and years of spider monkeys at a zoo. All right, they have some data listed here for us. It looks like our data is not ordered yet. So step 1, what we'd want to make sure we do is order our data from least to greatest. So looks like 14 is my smallest number, and then 15, and then 20, and then it looks like 26 and 27 are my next smallest, and then I've got 30 a couple times here, and then 33 and 35 and 36 and 38. Looks like I've got everything there. Okay. After I've ordered from my least to greatest, I need to find the different values of this 5-number summary. So that's my least number is going to be 14. That's kind of obvious. My greatest number is going to be 38. Again, that's kind of obvious. The next numbers that I need to come up with would be my median. All right, I'll work my way towards the middle. So canceling out one on the smaller end and one on the bigger end. And again, like I had before, just work my way to the middle. Okay, two middle numbers, but they're the same. So I'm going to split my data in half right here. So my median is going to be 30. Okay. And then, lastly, I need to find the first quartile and the second quartile. And remember, to find those, that's just the median of this set of data and the median of this set of data. So this would be considered the lower half. I'll write that in the lower half of my data, and this would be the upper half. Again, I just split my data in half, so this is the upper end and this is the lower end. Now, what's the median of my lower half? Okay, I'll do similar, work my way towards the middle. I'm left with two middle numbers, 20 and 26. Remember, one way you can find the middle of them is add them and divide by 2, or find the average of them. Or it might be, you might be able just to see it by looking at it. What's in between 20 and 26? Well, that would be 23. That would be our first quartile. And then same for my upper half. So working my way towards the middle. What's between 33 and 35? Well, that would be 34. So I have my 5 numbers. I've got my first quartile, my third quartile, my median, and then my least and greatest number. I would say that's the most time-consuming part of a box and whisker plot, is finding those 5 numbers that are essential to making a box and whisker plot. What you need to do next is you need to draw a number line that includes all of our numbers here. So I start with 14 and I end up with 38 here. I might go by 2s when I'm making my number line. We'll see if this is enough room. So I have 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 38. Looks like I'm good right there. Okay. And then I'll include my 5 different numbers that I have to choose from. So I've got, and it doesn't really matter which ones you plot first. Some people just like to go least to greatest. So my smallest number was 14. My first quartile was 23. So that would be between 22 and 24. My median was 30. The third quartile was at 34, and my greatest number was 38. Okay. The middle 3 I box. So here's one end of my box is my first quartile. Marked by the other end of the box would be my third quartile. And then I also put a line down my median. So there's the box of the box and whisker plot. And then I connect the first quartile and the least value with a whisker. And the same on the other end. Third quartile goes to the greatest value with another whisker. And there you have it. There is your box and whisker plot. All right, why don't you go ahead and pause the video now to try making a box and whisker plot for the On Your Own. Please pause. Okay, hopefully you ordered your data least to greatest. You found your median, your least and greatest, and your different quartiles. I will just graph here and start by making our number line. If you have questions on how to find the median or the quartiles, please let me know, and I can help you do that as well. And it looks like we go from 0 to 7. 6, 7. I can go one more. 8 doesn't really matter. Just going by ones. 2, 3, 4, 5, 6, 7, 8. The smallest value was 0. Oops, I forgot to. 0. My median was 2. I got my quartiles. I got 1 and 3. 1 and 3. And then the greatest number was 6, I think. So in my quartiles, I'll box. My median, I'll put a line through, and then I'll include my whiskers. It's usually helpful if you do your box and whisker plot a little bit above your number line. I didn't do that in this example just because I didn't leave myself enough room, but it's usually helpful if you do that. Again, any questions on that, please come see me and let me know. For the second example, now we already have a box and whisker plot made for us, and what we're trying to do is analyze it. So it says the box and whisker plot shows the BMI, or the body mass index, of a 6th grade class. You can use these BMIs. They make BMI calculators to kind of look at your body mass index. For the first question, it says, what fraction of the students have a BMI of at least 22? And the key word meaning at least. So at least 22 means 22 or higher. What fraction of our students have a BMI of 22 or higher? Okay, well, here's 22. And 22 or higher falls along this last whisker. And how can we tell what fraction of students have a BMI of 22 or higher? Well, if you remember from our what I'd kind of explained in the first step about box and whisker plots, they show us the 4 different quarters. Here's the first quarter. Here's the second quarter. And lastly next we have the third quarter and then the fourth quarter. We can break this down into 4 different quarters. So what fraction of our students have a BMI of at least 22? Well, only this last quarter, so that would be 1/4 of our students about have a BMI of at least 22. Letter B says, are the data more spread out below the first quartile or above the third quartile? All right, let's erase this highlighter so we can kind of see a little bit better. So are the data more spread out below the first quartile or above the third quartile? Okay, well, where is below the first quartile? Well, here's the first quartile and below, and here's the third quartile and above. So where is the data more spread out? Well, just from looking at this, you can tell that it's more spread out above the third quartile. But if you wanted to look at numbers, you could say this goes from 22 to 28. So that's a range of 1, 2, 3, 4, 5, 6. Whereas below is only a range of 1, 2. So that would be above the third quartile. And that would be because it has a range of 6 compared to 2 in the first quartile. And lastly, for letter C, it says find and interpret the interquartile range. Right? Really nice about finding that interquartile range in the box and whisker plot is you just look at the third quartile, which is 22, and you subtract the first quartile, which is 19. You're just finding the range inside your box. So what is 22 minus 19? That gives you 3. So the interquartile range of this data is 3. And that makes sense. These are called, this is the first quartile and this is the third quartile. What is the interquartile range? So what's the range in our box? And I'll just, maybe you want to write that down. That's the range in your box of the box and whisker plot. All right, go ahead and pause the video now to try number 2 on your own here and answer A, B, and C, similar to what we just did in the second example. For letter A, it says what fraction of the roller coasters are between 120 feet and 220 feet tall. So 120 feet and 220. Well, so right here, how many quartiles am I talking about? First quartile, second quartile, and the third quartile. So right here. So 3, I shouldn't say quartile, quarters. First quarter, second quarter, third quarter. So we're talking about 3/4 of the data. 3/4 of the roller coasters are between 120 and 220 feet tall. Letter C says, are the data more spread out below or above the median? And explain. So here's our median right here at 180. Is it more spread out here or is it more spread out here? Well, you can see that it's actually neither, or maybe you said both, because it's evenly spread out. The one range isn't bigger than the other. They have the same range. So it's a little bit of a trick question, I guess. And then lastly, letter C says find and interpret the interquartile range. So again, for that one, you're finding the range of your box. So you would take 220 and you would subtract 140 and you would come up with 80. Okay, and what does that mean when you're finding the interquartile range? That means the middle half of the heights. Remember, this is our median is 180. The middle of our heights vary by no more than 80 feet, because it can go 80 feet. It won't vary more than that for our middle set of our data. All right, we have the key idea and an example and an on your own left to wrap up today. This is kind of similar to what we talked about in the last section when we talked about skewed data. And it's similar where we have skewed left, symmetric, or skewed right. And in this case, what helps me think of skewed left or skewed right is to look at the whiskers. For example, the whisker in this box and whisker plot is a lot longer on the left-hand side, so we'd say it's skewed left, because most of my data is to the right. Symmetric, again, that means it's a mirror image of each other at the median. The median's in the middle of the box, and the whiskers are about the same length. And this one, my whisker is bigger on the right, so I would say it's skewed right, which means most of my data is on the left then. Okay, so let's use that for example 3. The double box and whisker plot represents the prices of snowboards at 2 stores. So in blue, the top store, store A, versus store B on the bottom, and we're talking about snowboard prices. A says identify the shape of each distribution. Okay, so for store A, let me use blue here, is my data skewed left, symmetric, or skewed to the right? Well, it looks like my median's in the middle of my box and my whiskers are about the same length. So I would say that this would be symmetric. Okay. And then for store B, I'll change to red here. Identify the shape of each distribution. This one, my whisker on is a lot bigger on the right. So most of my data is on the left. So my distribution would be skewed. It's a weird word to spell, right, because my whisker is longer on the right, and most of my data is on the left. For letter B, it says which store prices are more spread out and explain. So we can kind of look at a couple different things here. First, I'll look at the interquartile ranges of my box and whisker plots. The interquartile range for store A would be, looks like it's at about 370 minus 230. 370 minus 230 would give us about 140 for my IQR for store A. What would the interquartile range for this one be? I'd take 450 and subtract 300. So that would give me 150 for store B. And my interquartile ranges look very similar. The boxes look like they're not, like my data won't vary too far from my median. But let's also think about the range. So my range is my greatest number minus my least number. So for store A, it'd be 450 minus 150. 450 minus 150. The range that I could of snowboard prices from the least, the cheapest snowboard to the most expensive. For store A, it would be $300 is the range. And for store B, I've got 650 minus, that's my most expensive, minus my cheapest is 250, which will give me 400. So the range of prices in store B is 400. You can kind of tell that by looking at this. This one is more spread out. When they're asking for that, the spread out, you're mainly going to focus on the range. Okay, so store B has the greater range and the data is more spread out. All right, please pause for the on your own, number 3, and come back to check and see if you got it right. Okay, we're talking about crocodiles and alligators' lifespans. First, we need to say the distribution. For crocodiles, I would say that my whisker is longer on the left, so my data is skewed to the left. And for alligators, I would say that looks pretty symmetric. The median is in the middle of my box, and the whiskers are the same length. Okay. And then it says, which reptiles' lifespans are more spread out, and explain. Let's look at both the interquartile range and the range to be able to tell here. Well, I can just tell the box for the crocodiles is bigger, so the interquartile range is greater for crocodiles. You can just tell it by looking at the box here. So the interquartile range for crocodiles is greater. And also, if you look at their entire lifespans, the range for crocodiles goes from 45 to 80. Okay, so 80 minus 45 would give you what? 35 years range. And for alligators, it goes from 40 to 60, so that's only That's for croc. And it's 20 years for an alligator. So you can see that the range for crocodiles, the age range is also greater. So the interquartile range is greater, and so is the normal range. So more spread out would definitely be the crocodile. All right, that concludes lesson 4 here on box and whisker plots. Let me know if you have any questions, and good luck on the practice. I will see you guys next time.